Let's start looking for our like terms. So I see a 4m. Let's see if I see another term that has the same variable with the same exponent. And I see over here, I see another m. These both have the same variable with the same exponent of 1. So I'm going to record these first. 4m plus m. Next, I see a negative 2y, a negative 9y, and a negative y. So I'm going to add negative 2y plus a negative 9y plus a negative y. And then last, it looks like this negative 11, this constant term, is all alone. So I'm going to add a negative 11 at the end. And as you look across, you see that everything has a shape around it. So I made sure that I took care of every single term. And now I can start combining. You have to remember that when you see an m on its own, the coefficient is a 1. And we are focusing on combining the coefficients. So what is 4 plus 1? Well, 4 plus 1 is 5. So 4m plus 1m is 5m. Now here we are combining negative 2y plus a negative 9y plus this is actually a negative 1y. So think about it. This is just a bunch of negatives. I have two negatives. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives, and an extra 1 negative. So 9 negatives and 1 negative would be 10 negatives, plus another 2 negatives, that's 12 negatives. So I'm combining negative 12y with that 5m. And then this doesn't combine with anything, so I just tack on to the end that negative 11. So this is one way I could write this answer. I could also switch the order using the commutative property of addition. So I could put the negative 12y first, then the 5m, then the negative 11. There's actually many different ways for me to write this. So just know that as long as you make sure to keep the 12 a negative, the 5 a positive, and the 11 a negative, you can switch the order using the commutative property of addition.